Today we're going to talk about something called two-way tables. Now, if you think about this unit globally, this is a unit about two variable information. So we have been dealing with when we have two variables that are quantitative, right? So you have ordered pairs, you can make a scatter plot. Now, if you think back to unit 1, when we had one variable, in our one variable unit, we talked about having categorical data, and that led us to be able to do certain kinds of graphs, and we talked about doing quantitative data, both, so categorical and quantitative. So this is where we're making a little bit of a shift in the unit. It's still going to be looking at two variable situations, but instead of looking at the quantitative area, which is where you have scatter plots, we're going to look at the categorical situation, which is where you can't have a scatter plot, but you can have this thing called a two-way table. So if we were to do a survey about pets, and we restricted our attention about pets to just dogs and cats. Now, I'm fully aware that you can have other pets besides dogs and cats, but let's just, just humor me, okay? We're not looking at the turtles or the, ferrets or anything like that. If we were just asking about dogs and cats, the different options are just 4, okay? So you might own both a dog and a cat, or multiple, right? You might have cats and dogs, multiple, right? Okay, so that's a house that is both feline and canine. You might have only cats, you might have only dogs, you might have neither, okay? So both, one or the other, or neither one. Those are the 4 options. Now, with that in mind, you could make a chart, and this kind of chart is called a two-way table. There are 2 variables, the variable of dog ownership, so you either have a dog or you don't have a dog, and the variable of cat ownership, either you have a cat or you don't have a cat, and then the 4 options that we were just discussing moments ago are in this center part. Okay, so that's an example of a two-way table. If we asked how many cats and how many dogs you own, now that would be a quantitative variable, and we could go back to a scatter plot for that, okay? But if we just said, hey, put yourself in one of these groups, categorical variable. And a categorical variable, when I have 2 of them, can be represented in a two-way table. So let's say that our class turned out to be like this. Say we had a class of 24 people, and then turns out there's 3 people who both own dogs and cats, both. There is 1 person who owns a cat but not a dog. There are 18 people who have dogs but not cats. And there are 2 people who do not have any cats, they do not have any dogs at their house. Okay, and that adds up to 24. So based on our table, right here, I'd like you to pause the video and answer these questions. This is just me making sure that you understand how to read this table. Okay, so go ahead and pause the video and answer the 4 questions that you have in your notes. Okay, so here are your answers. How many people do not have a dog or a cat? That's these 2 people that are signified in that cell. How many people have 1 or more dogs? So for the dogs, you do need to add, okay? And so we need to look at, here are my dog owners, and add them up. Just like in the next question, having a cat is this row, and so I need to add that up. And then how many people have at least 1 pet, where we understand pet to be cats or dogs because we weren't looking at other animals. So that's everyone except this group, right? Do not have a dog or a cat was 2, and there were 24 people total, so that leaves 22 people owning a pet. Now, when you're looking at a two-way table, basically what you're looking at are some different kinds of numbers, okay? And so I have a two-way table here that shows grades like A, B, C, D versus being male and female. Okay, now this is greatly simplified. Obviously, it doesn't have pluses, minuses, it doesn't have Fs, it's gender binary, right? So there's a lot of things that are sort of like super simplified just to have this as an example. But I just thought I would point out that there are different kinds of numbers in a two-way table. So the part that I have a red box around, those are all just my internal cells, right? And so each of those cells represents some combination of male and female versus a grade, right? So for instance, this particular cell is identifying male and having a C average, right? And it would be a number there that was in row 3, column 1, right? So each of those is what's called a cell. If you add going across, add the cells, you'll get what's called a row total. So that's what we did back here. Having a cat, we said there were 4 people who had cats, and we added up across the row. There also are column totals. You might add going down and then get a total for that column. So this column that I just signified here would be males. Now notice when I have a row total or a column total, it is only about one of the variables. It is not about a combination of the 2 variables. It's ignoring one of the circumstances, right? So this row total would just be people who have A's. Didn't say anything about the other variable, only mentioned grades. And then there's what's called the grand total. The grand total could be found by adding up all of the cells. The grand total also could be found by adding up the row totals. The grand total could also be found by adding up the column totals. All of those should add up to the same number, okay? There are some questions underneath that, but I'm going to skip ahead to talking now about probability. So one of the great things that you can figure out relative to a two-way table are some different kinds of probability questions. Now, I would expect that within this part of the lesson, you learn 2 things. I would like you to learn the vocabulary, and then I'd also like you to learn how to do the problem. So please try to pay attention to both. We're going to talk about 3 different cases. The first case is something that's called joint probability. And you can identify joint probability because you typically will have the word and in the question. So for instance, we might want to know within our table, what is the probability that a person from our data set has a dog and does not have a cat? Okay, so that might be written like a P for probability, dog, and no cat, just to summarize, okay? So let's look at our table and let's figure out what cell that is. Having a dog, not having a cat is this cell. So the probability is going to be 18 out of my total, which was 24 people. So when I'm doing joint probability, it's noted here that you typically are going to be doing a cell count divided by the grand total. Okay, so if you know you're doing joint probability, you see that and cell over total. Conditional probabilities typically have the word given or if. It's like finding a probability, but within a subgroup rather than within the entire group. So an example of that would be, let's say we wanted to find the probability of owning a cat given that the person is a dog owner. So you can imagine this, instead of having the 24 people all be in the room, you're going to say, hey, I only want to look at dog owners now. So everyone who owns a dog stays and everyone else leaves. So how many dog owners did we have? We had 21 dog owners. And out of those 21, how many of them also had a cat? That's these 3. So my probability of owning a cat, knowing that that person already owns a dog, is 3 out of 21. So I'm not looking here at the whole group. I'm looking at a subgroup. That subgroup is going to be a column total or a row total. In this particular problem, it was a column total for dogs. And then I'm going to do a probability from that. Okay, so instead of having my bottom number be the grand total, it's going to be some subtotal. And then there's still a cell on the top. So cell divided by column total or cell divided by row total. And that's what I said down here. That's called a conditional probability. It's on the condition, right? So ours was on the condition that the person already owned a dog. The last kind of probability I will mention is actually, I think, maybe the easiest. It's what's called a marginal probability. And you can tell that you're doing a marginal probability because one of the variables is not mentioned at all. Okay, and so if only one of the variables is mentioned, you know you're doing marginal probability. Now, just to make sure you're clear, in our problem, the variables are dog ownership and cat ownership. So if I am only talking about one of those two things, it must be a marginal probability. So for example, maybe I want to know the probability that a person from this data set is a cat owner. Probability of cat owner. See how I didn't mention dog? Dog has nothing to do with it. So it must be a marginal probability. Okay, in this case, I'm going to have my bottom number be the grand total. And instead of having a cell on the top, like both of these other kinds had a cell on the top, right? One of the boxes. So 18 was my top, and in this one, 3 was the top. This one does not have a cell like one of the squares of the chart in the top. It actually has either a column total or a row total. In this case, we're looking for cats, which means I read across and get 4. So we have a 4 out of 24 chance that a randomly selected person from this data set would be a cat owner. That's called marginal probability. Okay, there's some practice problems at the end. Okay, there's this practice problem about a cycling club, and then there's a practice problem about hockey, and there's a practice problem about cars. I would like you to pause and try to do all 3 of these and then come back and check your answers, okay? For this first one, you are going to have to figure out this cell. And to do that, notice that it says that there are 40 children. Each child has 1 bike. So there's 40 bikes, 40 kids, okay? Same thing. It's not like someone owns 2 bikes and that's tricky or something, okay? So first figure out that missing cell, answer the questions, do the other 2 problems, and then we'll just come back and go through answers. Pause. Okay, I'm showing here my answers for the bicycle question, and you can see that in red I have my row totals, in green I have my column totals. The missing cell was 60. The answers to my questions are as follows. Question 1 asked me to find the grand total, which is 40. It also asked me to find the row and column totals, which I just pointed out to you. Question 2 asked how many children have mountain bikes. That is the first column's total, which is 11. Question 3 said, given that a child has a racing bike. Okay, so this has that word given. So that means this is a conditional probability. So given that a child has a racing bike, I am only looking inside of that purple box right now. So out of the kids who have a racing bike, which is 14 kids, how many of them are also 12 speeds? 6. So 6 out of 14 should be your answer. Now note, of course, in all of these questions, you could reduce the fraction, you could make it a decimal, you could make it a percent. But why, right? I mean, if it's fine answering it like that, let's do the path of least resistance, you know what I mean? Okay, here are my answers for 4, 5, and 6. What is the probability that a randomly selected child has a BMX bike? BMX bike is 15 out of the 40. Probability of having a 12 speed, you read across the 12 speed, there are 14 of them. And what is the probability that there's a bike that is a 15 speed and a mountain bike? So the and means I'm doing a joint probability, which is a cell out of the total. There are 2 15 speed mountain bikes, so 2 out of 40. All right, and then for these last couple, you had to really make your own chart. Now in this one, because I was just drawing myself, you might have had hatchback and not hatchback on the left edge, and then blue and not blue on the top. That's fine. Just check the corresponding boxes. You should have a 1, a 5, a 7, and a 7, and then your edge totals, okay? And then it did not ask you as a follow-up to figure out a probability. It just asked you to figure out a count. So that's actually kind of easier in some sense. There are 7 cars that were not hatchbacks and not blue. And then there was the class that was playing hockey. And you can see here what my totals were and that my answer to the question they asked is 12. hope that helped a lot. You are all set for doing problem set 2.4. Thank you so much.